Hi there. Thank you for clicking on this video. In this video, I wanted to address the question, why don't we use completing the square all the time? So we've got this strategy for solving quadratic equations, and we know the strategy can work all of the time. Why aren't we using it all the time? If you've studied completing the square in your classroom, or you've just watched some of my videos where we've talked about completing the square, you know that we typically only complete the square when the a value of our quadratic is equal to 1 and the b value is even. But what happens if we try to do it otherwise? Like, why is it such a bad idea to do it another way? So we're going to start with the idea, what if your a value is not equal to 1? So suppose you had this equation here, 2x squared plus 4x minus 3 is equal to 0. And you've got options. You could explore factoring. This one is not factorable, but you could use the quadratic formula, and that's what pretty much everyone would recommend is this one. You've got to go with the quadratic formula. Here's what happens if you try to use completing the square, and this is gonna get ugly, possibly to the point where we don't even really want to finish it. So there's two ways you can structure this, and I kind of debated which of these two ways do I want to show you in this video that I think would make more sense. Neither one of them are great, but we're gonna do this way where we add the 3 to both sides. Now, we don't have to start there. There are some other places where we could start. Okay, so we add 3 to both sides, and what that does is it's going to help us avoid a fraction at the front end of the solution. So we are going to collide into the fraction, but it won't be till a little bit later. Now, we can't really complete the square with that leading coefficient of 2. So the next thing I'm going to do here is factor out that 2. And this one actually comes out fairly nice because I do end up with the b value being even. That doesn't have to happen. So what I'm going to do here is complete the square with this inside portion. So I'm going to isolate that inside portion and just complete the square. So I'm going to take my b value, which is 2, divide it by 2 and get 1, and then square that one to get 1. I know that's a little boring, but and I'm going to add the 1. Now, here's where this particular strategy of adding the 3 to both sides is, as opposed to if we kept it on the left. I did not actually add a 1. I know it looks like I added a 1, but remember this 2 that I factored out. If I were to redistribute that 2, you would see that it's actually plus 2 because 2 times 1 is 2. So that 1, because I added it into a parenthesis that was being multiplied by 2, I actually added a 2. So if I want to keep this equation balanced, I have to actually add a 2 to the other side. Whatever you do to one side, you have to do to the other side. So really, over here, I added 2, so I have to add 2 here. Now I can complete the square here. So this will be x plus 1 all squared. That's assuming you know the process, so that number that we saved comes into play, and then 3 plus 2 is 5. Now, what this did is, like, we're not going to run into the fraction until here. Okay, if I kept the 3 on the other side, I can avoid that weird thing where we're got the 3 outside the parentheses and a plus 1 in the parentheses, but I would have ended up with the fraction earlier. You can kind of pick your poison on which way you want to do that. Now we're going to divide both sides by 2 to get x plus 1 all squared equals 5 halves. And then per the process for solving the equation, we're going to square root both sides. And we need to remember that that's going to be plus or minus on the right-hand side there. If you square root a square, you get just whatever's inside. And now we can subtract 1 from both sides, so we get -1 plus or minus that lovely expression there, which is debatable whether you're even allowed to leave it like that, because technically that's got a square root in a denominator. So it's possible you could go through this work with like square rooting this fraction, and then you're not even allowed to leave it like that. The square root of 5 halves is equal to the square root of 5 over the square root of 2. And then you might need to rationalize that by multiplying by the number 1 in the form of square root of 2 over square root of 2. So you get the square root of 10 over 2. Okay. And then maybe you can leave it like that, or you might need to get like a common denominator and play around with that some more. But you can see that this is probably much easier for you to arrive at if you just use the quadratic formula. So not only is it very error prone, but we're just really going around in a circle to get there. Now, let's also take a look at the other situation, which is what if you have an odd value for b? Now, this one is factorable. So your best bet for solving this one would be factoring, and then your next best bet would probably be using the quadratic formula, not completing the square, even though completing the square will work. So let's see how this goes. I'm going to do the same thing. I'm going to kick the 4 over to the other side. Okay, so we end up with x squared plus 3x plus something, is equal to 4. And then we take that b value and we divide it by 2. But now, because b is an odd number, this doesn't really simplify for us. So, 3 over 2 is 3 over 2. And then we have to square the fraction to get 9/4. And that's where we decide we absolutely love this method. We are going to add 9/4, and then we have to make sure that we add 9/4 to both sides. Now, the left-hand side is going to be factorable fairly easily, because if you've done enough completing the square, you know that that number that you saved is the number that goes into the factorization. But over here, we need a common denominator on those fractions there. And so that is going to give us 25/4. And now we can do the square rooting step. This one is factorable because I actually can take the square root of that. So x plus 3/2 is equal to plus or minus, that will be 5/2. And then we'll subtract the 3/2 from both sides. So we end up with negative 3/2 plus 5/2 and negative 3/2 minus 5/2. This will be 2 over 2, which is equal to 1. And this will be negative 8 over 2, which is equal to negative 4. Not the best way to do it. So does it work? Yes, absolutely. You can get there in both of these situations if your problem doesn't meet those strategies. And of course, you could also have a not equal to 1 and also end up with a b value that's odd. It's even more fun. But you can also see with this that it's just not the best method to use. So if that's a question that was kind of bothering you, why don't we use this method all the time? You can just see that this is inferior to some of the other strategies that we have available for solving quadratics. So I hope to see you in a future video. Check out some of the other videos on the channel to explore this in more depth.